Welcome to another lecture of our data structure playlist. Today we are going to learn about the need of data structure and its advantages, and also few other things. We will go to that later. So first see and check what are the needs of data structure. So to use data efficiently, that is the main need of data structure. I have already described and explained this thing in my first video of the playlist, that how we use data structure to use the data and information that we have efficiently. And what does we mean by efficiently? This means time efficiency and space efficiency. Also there is another need, that is to implement ADTs, that is abstract data types. So what we need to implement ADTs? We need data structures to implement ADTs. Suppose to implement the stack ADT or stack abstract data type, we can use two data structure, that is array and linked list. Okay, so we have two data structures we need or we can use to implement the stack ADT. So these two are the basic needs of data structure. Now let's check what are the advantages. So as I've already explained before, that the efficiency is the main advantage of data structure. Okay, so let's check it. Proper data structure can make program time and space efficient. Okay, so and the next is reusability. We can use a data structure multiple times. Once we have implemented it, we can use it multiple times. That is the reusability advantage. And the last part is abstraction. That is the whole point, that abstract data type comes into play. So programs doesn't have to worry about the implementation of the details. The program does not worry how we implement our data structure, but it only use it and it does not care about the implementation. So now let's come to an interesting part, that is the types of data structure. So the types of data structure, we can see there are two different types, that is linear data structure and non-linear data structure. So let's see what are these. For linear data structure, all elements are arranged in sequential or linear order. Okay, so in a linear data structure, suppose like arrays, all the elements are arranged how? All the elements are arranged in a sequential, that is one after another, and linear order. Okay, so this is like one after another. So this is linear data structure. And what is non-linear data structure? The elements are not arranged in any linear or sequential manner. Okay, elements are not arranged in a sequential manner. So that is non-linear thing. Okay, so now let's check the examples of linear data structure. These are arrays, stacks, queues, and linked list. Okay, so these all are linear data structure. And non-linear data structure are what? These are graph and trees. These are non-linear data structure. So you must know the difference between these two things. So let's check the difference between linear and non-linear data structure. So see, the data items are arranged in sequential order. That is the definition of the linear data structure actually. So from the definition of the linear data structure, we know that the items must be arranged in sequential order, and for non-linear data structure, the items are not arranged in sequential order or non-sequential order. Okay, so there is also another thing, that is the memory utilization is not efficient for linear data structure, but for different non-linear data structures there are different types of memory utilizations done. Okay, so different data structures utilize memory differently, okay, in efficient ways. Okay, so for the non-linear data structures, the memory usage or memory utilization is efficient, but that is not the case for linear data structure. Also linear data structures are easy to implement. Okay, these are kind of simple things, these are easy to implement, but there are complex implementations done for non-linear data structures. Also the time complexity increases with the data size for linear data structures, but for non-linear data structures the time complexity remains similar. Also let's see the other and also the last difference is that single level involved. Okay, so for a particular data structure, for a particular linear data structure, suppose have any example, suppose we are having an array here, there is only one level involved. Okay, suppose we are having an array with 4 elements, so there is only one level involved here. Okay, but what is for the case for non-linear data structure? There are multiple levels involved. Suppose a tree, we have many levels. Okay, different levels involved for a tree. So this is a tree and this is an array. This is only one level, there are different levels. Okay, so all the examples we have already seen it, so let's take it again. Array, stack, queue and linked list are linear data structure, and trees and graphs are non-linear data structure. Okay, so suppose tree, for we have different levels, there is 1 level, 2 level, 3 level. So okay, so suppose for this example we have 4 levels up and here we have only 1 level. Okay, so that is what I meant for my last point. So hope you understand and get the difference of these data structures, and we will be learning all the data structures, all of these data structures and their implementations one by one. But before that we will be learning something known as asymptotic notation. So let's see you in my next video.